In question number 1, you're asked to match the graphs of the three parabolas, A, B and C, with the following equations. Now clearly we're after the turning point format of the quadratic. In these cases, all 0, so we'll see how we can go. Firstly, this one here is of the form of having the turning point at 0, -2. So it's not actually there in the one I've got. It should actually be indicated like so. In the next one, -2x squared is a dilation, so that will be for B. And in the next instance, -x squared, -x plus 2 all squared. That means we've got a turning point of -2, 0. And we have the shape like so. So that will correspond with C. I'd now like to take you through question 3 that sketches that graph from go to woe. Now in this question, the y-intercept is going to be at -6. When x is 0, y is equal to -6, or the point 0, -6. The shape is going to take the normal quadratic type shape, smiley face if you like. Now we need a turning point, and we also need to locate the intercepts. I'll do the x-intercepts first. I take a third out as my common factor. So I've got my x-intercepts at x is equal to -6 and x is equal to -3. Now to locate the turning points, I'm going to do this by completing the square. You could also find it simply by the x value, -6 plus 3 over 2, and you'll soon find that gives you -3 over 2 as your x value, and you can substitute that in. When eventually you work that out, that will end up being, -6 3/4. I note in the answer is -6.75. So I can then graph it on that basis. I'll do that, then I'll come back and show you how we can make use of completing the square, which is a technique we will have to use as we proceed through. And when I sketch my graph, it only has to be approximate. My y-intercept of -6 go there. We've got -6 here, 3 here. I get to label the x-axis, and just move that up so you can see. And the turning point -3 over 2. We can then sketch the graph fully. Now in a moment I'll show you how to locate the turning point by completing the square, which is a skill set we will need to make use of. So as before, I take the third out, and I'm left with x squared plus 3x, close the bracket, -6. Halve and square the coefficient, the 3 there. So end up with x squared plus 3x plus 3 over 2 all squared, and -6 minus a third times 3 over 2 squared. I've got a perfect square of x plus 3 over 2 all squared, and when I sort out the other business, I'll have -6 3/4. Now, when I go through the rest of this question set, I'll generally find my turning point by completing the square.